In this problem, we need to find out the range of k where it is given that n minus 1 CR is equal to k square minus 8 into NCR plus 1. This is a problem which appeared in JEE Main 2024. It's a very easy problem, but if we only understand the concept of the properties and everything regarding NCR, okay? The permutation combination or maybe the binomial theorem, wherever you read it first, okay? That's it. So let's go ahead and solve this particular problem. To find out the range, obviously we first consider the given relation. Now we observe that, right, that n minus 1 CR, right, is properly defined, right? So when it is NCR or anything is properly defined, right, we know that NCR, right, is properly defined, right, when n and r are integer and obviously n is greater than r, right? That's the condition. So therefore we can say that here n minus 1 must be greater than r. That is, n must be greater than r plus 1. Also, we can see that NCR plus 1 is properly defined. So therefore, n must be greater than r plus 1, right? That's it. So the condition to being that relation will holds good if n is greater than r plus 1. So this is a common relation and we have to remember that. Let's go ahead. Find out a relation between n and r which states n is greater than r plus 1. Now we apply the definition of NCR and we expand the left hand side and right hand side. Okay, that's very simple. Okay, now observe that, right? If we apply the properties factorial n is equal to n into factorial n minus 1, using that we can rewrite the following relation. So here we can easily observe what we perform. So factorial r plus 1 we written as r plus 1 into factorial r and factorial n written as n into factorial n minus 1. Why? Because observe that here then n minus 1 factorial cancel from both sides. N minus 1 minus r factorial is present, so that is also cancelled out, and r factorial is also cancelled out. So therefore by simplification we find 1 is equal to k square minus 8 and the remaining n by r plus 1. So therefore k square minus 8 can be written as using cross multiplication as r plus 1 divided by n. Now observe, right, that n is greater than r plus 1. That's imply n divided by r plus 1 is greater than 1. So if I reverse it or reciprocate it, we find r plus 1 divided by n is less than equal to 1. So we find out the upper limit. As well as r plus 1 and n are also integer. So therefore the ratios of two positive integers, right, must be greater than 0, right? So these are should be positive integer, right? Because r plus n if are not positive integer, then NCR or n plus 1 CR, these are not defined. So therefore the ratios r plus 1 and n lies between 0 to 1. Now why it should not be 0? Why we consider it as a open interval? That's the concept. Because see that, right, if n is equal to 0, no, n cannot be equal to 0, right? Because if n is equal to 0, it's not properly defined, right? So that's why n cannot be 0. And also, right, r plus 1 cannot be equal to 0, because if r plus 1 equal to 0, r is equal to minus 1. Now if r is equal to minus 1, n minus 1 CR is not defined, right? So that's why we can say that it is greater than 0, not greater than equal to 0. So therefore we find k square minus 8 must lies between, right, must lies between 0 and 1. Obviously 0 is not included, 1 is included. So let's go ahead. Now we find out the range of k square minus 8, right? So if I add 8 both sides, it lies between 8 to 9. Okay, that's it. Now if k square is less than equal to 9, which imply that k belongs to the interval minus 3 to 3, both are included, so it's a closed interval. And second case, right, if I plot it, right, we consider that minus 3 to 3 and k lies inside this, right? That's it. If I go ahead, right, and choose the second condition that k square is greater than 8, so that means k belongs to minus infinity to 2 root 2 and 2 root 2 to infinity. So you just mark 2 root 2, and obviously that is lies between that 0 to 3. So therefore minus infinity to 2 root 2 and infinity to 2. Okay, that 2 root 2 to infinity, right? So that's the second case. Now what is our range of k, so that the given relation is defined? It will be the intersection of these two interval. So what is the intersection, right? So the intersection will be, right, that minus 3 will be included, 2 root 2 will not be included. Similarly, 2 root 2 not included in the other side, and 3 is included. So therefore, the interval will be k belongs to minus 3 to 2 root 2 and 2 root 2 to 3, and both are union. And hence, the option A is the correct answer. And that's it. Hope you understood the problem. Thank you.